spin and antimatter. From the south coast of the island, the weather to the southeast looks grim and forbidding. The more superstitious crew member fear that we will be lost in the deeps, or even off the edge of the world, if we set out in that direction. But with the Dirac equation and its matrices and its vectors containing the 4 quantum fields where we used to have one, we have constructed a vessel worthy of the journey, and it will take us on one of the most remarkable expedition in the landscape of the particle physics. One thing which gives us the confidence in our new vessel is that in developing it, we have solved an old puzzle we came across in the atom land. On that expedition, we made the observation that the electrons bound to the atoms were confined to the particular energy levels. A curious fact that was also noted was that each level cloud only hold 2 electrons. There is no argument about this fact. The whole of chemistry and spectroscopy back it up. But why 2? Even if we accept that there is some limited occupancy, that we can't stuff lots of the electron into the same energy level, the 2 seems a strange number to allow. Why not just 1? Why not 10? Yes. The exclusion principle behind this is built deeply into the quantum field theory we used to describe the electrons and indeed all quantum particles, and as is very often the case, it comes down to the symmetry. Yes, symmetry, that is why there is only 2. It comes down to the symmetry. Yes! Mirror image. Yes! That's why only there is 2 direction. Wow. Oh yes. In this case, it is a symmetry under swapping pair of the identical particles. Yes. In this case, it is a simply under swapping pair. Swapping pair. Don't think about any naughty things, right? Of the identical particles. That's a fairly trivial sounding symmetry. One would think that a swapping pair of identical particles makes no difference to anything. By definition, they are identical, yes. But in the quantum mechanics, that's not quite true. The probability of measuring a real physics property depends on the magnitude of the quantum field, not on its sign. Wow. So again, it depends on the magnitude of the quantum field, not on its sign. So it doesn't matter whether it is identical or not identical. It's only a matter of the magnitude, which is scalar, right? Not vector. Minus 1 and 1 both have the same magnitude. 1! Yes! It's like a square root of the 1, and then the square root of the 4 is plus minus 2. There is 2 answer. There is, yeah. Wow. So, swapping over 2 identical particles will obviously have no effect on the physical observables if it has no effect on the quantum field. That's trivial. But it will also have no effect even if it flips the sign of the field to minus whether the original value was. Wow. Really? So it's only a matter of the magnitude indeed. Quantum particles seems to exploit all available opportunities to be weird, and some particles behave in the first way, no change in the field or the observable physics, whereas others behave in the second way, change the sign of the field, but still no change to observable physics. The first kind of the particles are called bosons. The second are fermions. Now what is the chance of having 2 or more identical electrons in the same energy level in an atom? We have to, as usual in the quantum mechanics, sum up all the different possible ways. Electrons are fermions. So there are 2 possible ways according to this exchange symmetry. One with the particle swapped, one unswapped. but these have identical quantum fields behind them. Apart from the different sign, they will cancel out, just like the waves in the bay could arrive out of their face and leave the seagull becalmed. If they cancel out, the probability of having two identical electrons in the same energy level is 0. Yes. That's the exclusion principle. It shows how the energy levels can get full, but it does not yet explain why there are two electrons in each energy level. According to the exclusion principle, there can be only one, unless the electrons are not identical. Oh, see, so electrons are not identical. So, but in reality, electrons are identical. That is why there is two electrons, right? And the Dirac equation just shown us that the electron has to correspond to 4 quantum fields. Electron has to correspond to the 4 quantum fields. Two of these explain the double occupancy of the energy levels in atomland. They correspond to the different spins of the electron. Spin is an intrinsic angular momentum. Angular momentum, yes! Spin is an intrinsic angular momentum that electrons have, almost as though they were really spinning. It is a very important property of the particle, dictating a lot about how it behaves. Yes, electrons have half a unit of spin, which can point in one of the two directions, say clockwise or anti-clockwise. The spin means electrons generate a tiny magnetic field as well as the electric field due to their charge. This magnetic field affects how they bind to atomic nuclei. It can be measured. For example, if an atom is placed in a strong magnetic field, each energy level splits into two, because when the magnetic field due to the spin is aligned with a strong magnetic field, it has a different energy to that which it has when it is aligned. These split in energy levels have been precisely measured. The Dirac equation tells us why they happen. Wow! The exclusion principle and whether the particle is a boson or fermion is in fact intimately wrapped up in the matter of spin. Wow, it is all about matter of the spin. Fermions such as the electron have half integer spin. Yes, that is why that is 1/2, so fraction. Bosons such as a photon have integer spins. Yes. But what of the other two components in the Dirac equation? This is where we launch our new boat and head south into those storms. Is it storm really? Aren't you under danger heading to such a direction? At the time of Dirac's result, there was no physical property like a spin waiting to be explained by these components. They look a bit like the negative energy solution that plugged us earlier, but rather than the negative energy, they describe the particles that have an opposite charge to the electrons and identical mass. No positively charged electrons were known. This was a problem for Dirac, and he wrongly suggested that the proton might be so-called antiparticle of the electron, even though their masses are very different. He did not need to worry. Physicists were busy photographing the fragments produced when high-energy particles from their space hit the Earth's atmosphere. Within a very few years of Dirac's prediction, tracks were seen in these photographs which indicated from the distance they traveled and the way they curved in a magnetic field that they had the same mass as the electron, but were positively charged. They were named positron. Yes, they were named positron, the antiparticle of the electrons. electron, as we have built better dictators and detectors, not dictators, detectors and high-energy accelerators, antiparticle for all the other particles described by the Dirac equation have since been found. This is what we find as we sail south. The world is a globe, not a flat plane. There is an equator, and sailing over it reveals a whole new landscape. Yes, the hemisphere south of the equator is the antimatter. Wow! The hemisphere south of the equator is the antimatter, and the new vessel that takes us there is the Dirac equation, powered by the mathematics, relativity and quantum mechanics. Thank you for mathematics. Every type of particle we discover north of the equator has its southern antimatter equivalents. Positrons for the electrons, antiprotons for the proton, and so on. Wow! The antimatter is one of the more astonishing concepts in the landscape of particle physics. In the science fiction, it appears as a weapon of awesome power, destructive or otherwise, largely because when the matter and antimatter meet, they annihilate one another in a blaze of the released energy. Yes, in the real life, it has perhaps surprisingly been put to use in medicine before the warfare. Yes. It was a stunning prediction of the new physics pulled right out of the human imagination and reason shortly before the experiment would reveal it to be correct. Yes. For all its starring role in the science fiction, antimatter is a science fact. A whole new hemisphere of physics was made accessible by the exploratory power of some rather esoteric mathematics. The mathematics told us something startlingly new about nature, but perhaps an even more profound shock is what the observable existence of the antimatter tells us about the connection between the abstract mathematics and physical reality. Yes. The fact that the vessel we build have such a range and power is astonishing. To add the icing on the cake, just before we turn back towards the island on which proto-electron is found, another coastline drift past in the mark. One of the more experienced sailors informed us that this is the land of Bosonia, and it is there that the photons we have come across so often on the road originate. This is clearly a country to be visited on the future trip. For now, we have business back near Port Electron again. Really? See you.